Hello, welcome to the Machine Learning at Home. Today I will speak about one of interesting methods of dimension reduction. So everybody knows about principal component analysis, but there are much more interesting methods. Some of them are projections. Projections are famous because they are easy to interpret, and they also do not change things non-linear way. So all distances between dots are more or less safe in the projection. So projections where you will need when you need to retain the whole shape of your object in multidimensional space and project it in a little dimensional space, typically like 2 dimensions, the plane. So PCA is number one, but there are also independent component analysis. So let us load library. Fast ECA. ECA stands for Independent Component Analysis. So if you don't have this library, please install it with install.packages FastICA. This library was developed for unmixing of signals. So basic idea of ICA is not exactly thing like PCA. This is situation, for example, when you sit in a restaurant and hear multiple conversation from different corner and you want to unmix them to separate one conversation from all others. This is a very interesting task, and ICA is one of approaches. But I will use it today for dimension reduction, because this analysis also able to find interesting projection, as they say, some projection which will reveal internal features of the object. With this projection will try to separate object which is kind of in multidimensional space in such a way that you will see components which are more or less random themselves. So, for example, if there is a mixture of 3 species, each species internally is more or less random, but differences between all 3 are non-random, and this is exactly what ICA will do for you. Let me show how it works. ICA is stochastic method, so I will kind of freeze random number generator. Then you will see the same output as I see right now. So for example, set seed 1, maybe any other number. So now I will make this analysis. It's a fast ICA, so normally it's slow, but this library provides us a very fast way of ICA. So I will name my object. I will start same iris data as usual, and the function is fast ICA, and I will take iris data without column number 5, without -5, and then I will need to tell IC how many independent components I want. So how many dimensions if we translate this to the language of dimension reduction. Typically I want 2 dimensions. So ncomp equal to 2. That's it. Fast, as you see, and now we can plot it and see what's going on. So plot iris fi. So iris fi contains multiple components. We need component named as uppercase. This so-called source matrix, kind of matrix of independent components, which now unmix it. And I will colorize it with species. And I can also label xlab as source dimension 1 and ylab with source dimension 2, just to make it slightly more pretty. This is it. Looks like I did it right. Let us run it. Okay, that's a plot on the left side. Please look on the plot. it is very, very similar to principal component analysis. Not exactly the same and based on different principles. So, if by some particular reason PCA does not suit you, you can use FastICA. FastICA tried to find three, or actually most non-random parts and project exactly to see them best. So as you see here, there is a non-random splits between two pieces and two others, and more or less well done split between second species and a third one. Very typical. So that's very typical for these three iris species. Within each cloud, situation is much more random. A statistician says much more Gaussian. And ICA trying to find this particular projection. So it is projection pursuit. And result is again similar to PCA, but has different origin, different algorithms, which might be useful in different purposes. So this is it for today. I just wanted to tell you about this interesting, in rarely used, unfortunately, I would use it more often, rarely used method of dimension reduction. Thank you very much.